A slope field is a graph that shows you possible solutions to various functions. We'll first need to define some terms. The slope is the incline of a function at a given x or y value, or the rise over run. The derivative is a function that is used to determine the slope at any point of another function or functions. The tangent is an imaginary line that touches a function at only one point, and it's used to find the slope. In this example, we're given the derivative of a function, x squared plus y squared plus 1. So we want to plug x and y values into the function to see what the slope would be at that point. So we're going to do a couple points to show where the slope is at the given points on the original function. So once we have the slopes at our given points, we're going to now plot them onto a graph. Slope fields let you solve a function graphically without using a calculator. They're usually created by a software because of how long it takes to do it by hand. They can be used to maximize efficiency of a computer program. It will let you see where you want to be and then let you trace the most efficient path or function to that point. An architect might use a slope field to determine the best way to make a sewage system so it doesn't overflow. Growth and decay is a means of determining the amount left of a substance after it's grown or decayed. Growth is the increase of a given amount, while decay is the decrease of a given amount. An exponential function is a function that increases or decreases logarithmically using the exponent. E is the limit of unrestrained growth. It's just a number. The natural log is just a log with base e. The growth and decay equation is Pt equals P naught E RT. Pt is the amount left after a given time, P naught or P sub 0 is the amount at the beginning, E is just a number, R is the percent rate of growth, and T is time. A certain type of bacteria increases continuously at a rate proportional to the number present. If there are 500 present at a given time and 1,000 present 2 hours later, how many will there be 5 hours from the initial time given? The first thing we're going to do is plug everything that we can into our equation. Since there was 1,000 present 2 hours later, we're going to define our remaining as 1,000, while we define our initial amount as 500. We're also going to put 2 hours in for the given time. Now we just have to simplify it. You're going to have to take the natural log of the function so we can cancel out the e. This is our percent rate of growth. Now to figure out how many there will be after 5 hours from the initial time, we're going to have to solve for P5. So we're going to plug everything in that we know, and then we're going to put time in as 5. And once you solve that, you get P5 equals 2,828.427 bacteria. Now there can only be a whole number of bacteria, but this is just the math that we use to get to that. So in reality, it would be 2,828 bacteria. Exponential growth and decay can be used to measure how fast mold grows in your house. This would be helpful if you had a sickness going around and you could trace back when the mold started growing to when you started getting sick to see if there's any correlation. A demographist measures population growth. They'll use growth and decay to determine when a population is growing too fast or too slow. They can use this information to learn how ecosystems work and which species are invasive in a certain area.